Hello again, math nerds and science geeks. This is Alex from alexplayshelp.com. I have another geometry video for you. I'm going to show you how to draw inscribed and circumscribed circles. So what are these things? Circumscribed circle is any circle that lies along the points of a polygon. You can see how I manipulate these points right here. How the circle touches all 3 points of this triangle. That's how I've defined it in this program I'm using. I'm using a program called Geogebra. It's a free geometry program you can download. I'll have these applets I'm using on my website so you can download and play around with them yourself. This is a circumscribed circle. An inscribed circle is a circle that lies tangent on the insides of all 3 sides of the triangle. This one's a little bit harder to draw, so I'm going to start with the circumscribed circle. So, first thing you need is a triangle. Boom, 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 boom. Any 3 points will do, as long as they're not collinear. If they're collinear points, it won't work, because the center of the circle will lie at infinity, which, if you have enough time, you can reach, but you will never reach it. So, the center of the circle lies at the intersection of the perpendicular bisectors of the 3 sides of this triangle. This is the circumscribed circle. So we need to get the perpendicular bisectors of these 3 sides, because these 3 sides will form what are called chords of the circle. I have another video showing how to find the center of a circle if you already have the circle. It's the same process, except this one's kind of in reverse. So we need the perpendicular bisector. So from this first corner up here, we draw a circle that has the radius of the entire side. We draw that circle first, and then another circle. The intersections of these 2 circles form a line. 2 points, and then draw a line. The line between the 2 intersections forms the perpendicular bisector of that one side. You can see how I move it around. It stays in the middle and perpendicular. So that's the first one. So I can turn these construction lines off, the circles, and just leave the line in place. I'm going to do the same thing for the other 3 sides. Oh, make it a little smaller. Here's one here. The center of the circle is here, and it extends out to this corner. Here's the other one. Connect the intersections, draw a line. This forms the second perpendicular bisector. And you can erase the construction lines, or the construction circles rather. Where these intersect, see how it moves, that's the center of the circle. These 2 sides form chords of the circle. And for just completion, you don't have to use the other side. You only need to do it with 2 sides, but I'm going to do it with the 3rd side with this green circle. Here's another perpendicular bisector, just to show you that they all intersect at the same point, because we have 3 chords. Look how all three lines intersect all at the same point. This forms the center of the circle. And all you have to do is draw a circle, or you put your compass point where these lines intersect, extend the pencil out to the edges of the triangle, the points of the triangle, and then they'll all form at the same radius. Now notice what I said earlier, how the lines can't be collinear. Watch what happens when I make them collinear. Circle extends out to a line. All 3 lines become parallel, and you don't have a circle anymore. But if you can bring it back around, it comes to the other side. So you can't have collinear lines. They have to form a triangle. You don't have to draw the triangle. I have a triangle drawn here so that you can see it easier, but you don't have to have the triangle. So anyway, that's a circumscribed circle. What about an inscribed circle? It's a little bit harder, but not impossible. Start with a triangle again. The circle is going to be tangent to all 3 sides of this triangle. So if you have a circle that's tangent, the center of that circle is going to be on a line that is bisecting the angles of the triangle. So we have to get the angular bisectors of the three sides of the three corners of the triangle. So to do that, you need a circle of any size at one of the vertices of the triangle. The circle will intersect two sides at the same distance. So you have two lines here that are the same length. The circle will intersect them, and you can find the perpendicular bisector of those two intersections. Since these sides are the same length, these circles will be the same radius. So the perpendicular bisector of this segment right here will also bisect the angle. And you can read up on that a little later. I'm not going to get too deep into that, but when you connect the intersections of those two circles, you form an angular bisector. See how the angle stays the same on each side as I move this point. As I move this one, it gets bigger, but both sides of that angle will be equal. And now that I have the angular bisector, I can erase the construction circles, and the angular bisector stays in place. When you're using Geogebra, there's an automatic function for finding the angular bisector. But if you don't have Geogebra and you just have pencil and paper and a compass, you can find it manually. It's a pretty nifty technique for finding an angular bisector. So then we need to find the other angular bisector, which I'm going to use this corner up here. Same process. A circle will intersect the two sides at 2 points, which forms a segment, and you find the perpendicular bisector of that segment. Points where the circles intersect, angular bisector. And then now that you have the bisector, you can erase the construction circles because you don't need them anymore. These lines will intersect at the center of the inscribed circle, because the center of the circle, if it lies on one angular bisector, it's going to lie on the other two angular bisectors as well, if it's an inscribed circle. So we know where they intersect, they share a common center. So just for completion, I'll draw the other angular bisector just to show you that all three angular bisectors will intersect at the same point. Notice how I move it around, they'll intersect at the same point. That's where the center is, but you don't know yet what the radius is. You could fumble around with the compass a little bit to try to guess, but if the circle is inscribed, that means that the circle is going to be tangent to all three sides. So a radius of that circle is going to be perpendicular to the sides. And I'll draw a perpendicular line here just to show you that that's this other line I have right here. That's going to be the radius of the circle. It is perpendicular. It'll stay perpendicular. And that is the same. This point in the center is equidistant from all three sides. And once you have that radius, you can take your compass, measure out that radius, and then draw your circle. And that is how inscribed circle. And to show you, like side by side, what an inscribed circle and a circumscribed circle look like, I'll get rid of these construction lines, and I'll plop down a circumscribed circle. That's a little big. Let me shrink it down a little bit. And this is what they look like along the same triangle. You don't technically have to have a triangle, but it's really tough if you don't have a triangle, because you can have to make a quadrilateral, but then it's a little tougher because the points have to be along a circle, and that's a little harder. It's just easier if you have a triangle. So that's how you draw an inscribed and circumscribed circle. If you go to my website, alexplayshelp.com, I'll have these applets available to download and play with on the website, so you can see what this is all about for yourself. And if you have any math or physics homework problems that you're having trouble with, I have a form on my website where you can submit them, and I'll make a video and show you how to do them. Thanks for watching.